Welcome to today's session. Welcome to Discrete Learning Institute. My name is Isaac, and we are going through tutorial sheet 3 on integration. So this is further integration, where we have some questions here to integrate using integration by substitution. So how do we go about integration by substitution? So usually, whenever we see a function, an implicit function, where you have a function in another function, we use integration by substitution. This is also called, in other terms, it's called the reverse chain rule, because remember, when you are using the chain rule, we usually use the chain rule to differentiate. Now, if you have a function f of x is equal to ax plus b to the power n, a function like this, when you're differentiating, you use the chain rule. But if I'm integrating a function similar to this one, ax plus b to the power n dx, you use integration by substitution, which is also called the reverse chain rule. Also, whenever you have a function in another function, when you have a composite function, you use the reverse chain rule or integration by substitution. So this is what we're going to look at. We're going to discuss all that using the following questions. So I'll start with the first question, the first part. So I have part A, which says integrate 2x e to the power x squared dx. So you want to integrate this by substitution. So you can see here that you have two functions, 2x and another function e to the power x squared. So how do you integrate this using substitution? So what you do is you look at the question to say, okay, I want to do integration by substitution. You have to let u to be a function, and then you find du dx, and then you make dx the subject of the formula. So that same function you're letting to be a u, it should be in such a way that at least it should cancel with this x, because when you're using u substitution, you are trying to change a function from a function in terms of x to a function in terms of u. So that's what I'm going to do here. I can see that, okay, the best part here, I can see that this is like a composite function, which is e to the power x squared. This is an exponential function, but the x squared is an algebra. So I can see that I have an exponential function, but inside that exponential function, I have an algebra, which gives me a composite function. And then I need to use what? Substitution. So how do I go about it? We follow the following steps. So you let u to be that function, which is x squared, the algebra, and then you find du dx. So this is u, a function in terms of x, so that's why we're finding du dx. Differentiating this using the power rule, you have 2x there. You have 2x. And then what do you do here? You make dx a subject to the formula. So making dx a subject to the formula here, I'm going to have du, so you cross multiply, it will be du is equal to 2x dx. And then if you divide both sides over 2x, you are going to get your dx equal to du over 2x. So this is my dx and this is my u. So this integral has changed now. It will now be equal to the integral. I still have my 2x here. I haven't done anything to it, but I have e. What is x squared? Remember, we let u to be x squared. So x squared is equal to what? Is equal to u. And then what is dx? Well, just from making dx a subject to the formula there. So this is du over 2x. Du over 2x. And then here you can see that the 2x and the 2x can cancel here. So the 2x and the 2x goes, and then you have a function, the integral of e to the power u du. So you've changed the integral from an integral in terms of x to an integral in terms of u. That's the whole purpose of using the what? The u substitution. So after you change that integral, you can now simplify your expression by saying what is the integral of e to the power u. So remember, this is just an integral in terms of u. You are given that list for integrals, so you need to know the list of integrals, you need to know them so that it is easier for you to just see that, okay, this is just e to the power u, and then remember, the integral of e to the power u, it doesn't change, it's still e to the power u. So this will be equal to e to the power u, and then remember, this is what? An indefinite integral, so you put a plus c. But we are not done. Remember, the original integral was in terms of x, so the final answer should also be in terms of x. But, well, I can do that because my u is what? X squared. So this is e to the power x squared, then plus what? Then plus c. So that's your solution for part A. If I go to part B, I'll use the same scenario. So that is the integral of 3x squared, and then x to the power 3 plus 7 to the power 5 dx. So this one, how do you choose which one to let it be a u? So mostly for this type of function, you let u to be the function which is inside the brackets there. Most of the times you see that you'll be getting the correct solution when you do that. So you let your u to be equal to that function inside is x to the power 3 plus 7. So we follow the same steps. What do? You find du dx. So the steps don't change. You find du dx, and then this gives you what? So the derivative of 3x, x to the power 3 is 3x squared. So that's my du dx. And then you make dx subject to the formula in a similar manner. You cross multiply. Du is equal to 3x squared dx. And then you make dx subject to the formula here, dividing both sides over 3x squared. Dx will be equal to 3x squared over what? Over du. Oh, sorry, rather du over 3x squared. Du over 3x squared. Yeah, sorry. Okay, so this will be du over 3x squared. Du over 3x squared. And here, what do? We just substitute. So hopefully I'll have enough space. So this is equal to, so I still have my 3x squared there. Remember, this is the integral we're dealing with. 3x squared, but what is x to the power 3 plus 7? Remember, we have to let that to be our what? Our u. So to be multiplied by u. So the x to the power 3 plus 7 is to the power 5. So to be u to the power 5, then multiplied by dx, or just for making dx substitute the formula there. So it would be du over 3x squared. And then what do you do here? You can see that the 3x squared and the 3x squared cancels. This becomes the integral of u to the power 5 du. So you have now an easy integral, which you can easily integrate by saying, remember, when you're integrating, you add the 1 to the power, and then you divide by the same. So that's u to the power 5 plus 1 over 5 plus 1. Then this is an indefinite integral. We add the plus c. And then this will now be equal to u to the power 6 over what? Over 6 plus c. Again, remember, we have to write this in terms of x. So what is u? You replace the u back, write it up here. So the final solution will be, you replace the u with x to the power 3 plus 7. That's x to the power 3 plus 7 to the power 6. Then divide this over 6. Then you have plus what? Plus c. So that would be your solution. So this is part A and part B of our U substitution. So usually the methods don't change. What you just have to understand is you have to remember your derivatives, you have to remember your integrals for most functions, especially trigonometric functions, exponential functions, logarithm functions. So you have to know the derivative of all those functions. That's when you're going to enjoy integration, and specifically further integration. So now I want to do all of them. So I'll now look at maybe just to explain on part D. So part D, basically it's the same idea. So usually there's a simpler way to. Sometimes you are not told which method to use because remember there's integration by parts and substitution. So sometimes if they haven't specified in the question which one to use, you can always use this trick where if you have similar functions, remember we have different types of functions. We have logarithms, we have inverse trigonometric functions, we have algebras, we have exponential functions, we have trigonometric functions. So if you're not sure which one to use, just know that if you're dealing with the same functions, mostly it means you have to use what? It means you have to use U substitution. And then most of the times, if you have two different functions multiplying, let's say you're multiplying an algebra with an exponential function, then you use integration by parts. But sometimes a question that requires integration by parts can also be solved using U substitution. So there's always that. So, but mostly that's how it is. So here I can see that I have similar functions. I have sine and I have cos. So you can choose which one to let to be a U. So here, the easy way is for me to let U to be this one that has a power, because remember, this is the same as the integral. Remember, sine 3x is the same as sine x to the power 3, like this. And then you have what? Cos x dx. So it's easy for me to let this guy inside the brackets to be my U. So I'll let U to be that same function, let U to be sine x. So because it is easier to let U to be whatever is inside the brackets there, which has a power. So if we let U to be sine x, then we'll use the same methods. You find du dx. So du over dx here is what? So the derivative of sine x is what? Cos x. And then you make dx subject to the formula, you cross multiply, you have du is equal to cos x dx. If you divide both sides over cos x, you make dx subject to the formula by having this expression du over cos x. And then what's the next step? We just replace in that integral and simplify. So let me replace it from here. So this is equal to the integral. So sine x is u. So this is going to be u to the power 3 multiplied by, I still have my cos x here, then multiplied by dx is just du over cos x. Du over cos x. And here you can cancel out the cos x to have the integral of u to the power 3 du, which is an easy integral to evaluate. So what's the integral of u to the power 3? That's u to the power 3 plus 1, which gives me 4, over 3 plus 1, which gives me 4. Then plus c, because this is an indefinite integral. And don't forget to replace the u back, because you have to write this in terms of what? X. So that's sine x to the power 4 over 4, then plus what? Plus c. So that's your solution to part E. Yeah, so let's now try to evaluate part E. Part E, let me just rub. So to evaluate part E, we use the same idea there. You let U to be mostly here, whatever is inside the brackets, it's easier to do that. And then you evaluate using the same methods. You find du dx, make dx a subject, and then you replace back. Okay. So part E says I have the integral of sine 2x, then the square root of 1 plus 2 cos squared x dx. So remember that this is just the same as the integral of sine 2x. What is 1 plus 2 cos squared x? This is just 1 plus 2 cos squared x to the power half. Then dx. So remember, your root is just half. So I have this expression. And then using U substitution, I'll just let U to be equal to 1 plus 2 cos squared x. So 1 plus 2 cos squared x. So what is the derivative of this? So du dx. So du dx here, it's equal to the derivative of 1 is 0, then plus 2 cos squared x. So how do you differentiate cos squared x? So here you use the what? You use the chain rule. So remember, if I have a function that has that's in this form, f of x to the power n, you use the chain rule, where you say you drop the n, you use sort of a power rule. So you drop the n here, then you still have that f of x, then subtract the 1 from n minus 1. But since you have another function inside, you don't forget to multiply by the derivative of the inner function. So you multiply by f prime of x. So this is the chain rule. So it's what we're going to use here, because remember, cos squared x is the same as, and just write it up here, it's the same as cos x, then to the power what? To the power 2. So it looks exactly like f of x to the power n. In that, my f of x is now what? Cos x. So I'm write the answer here. So this is 0. But remember, I still have the 2. Okay, let me just integrate, differentiate it from here. So you drop the 2 here. It will be 2. And then you have cos x inside. Cos x, let me put the brackets there. And then 2 minus 1 is 1. Then you multiply by the derivative of what is inside. So what's the derivative of cos x? That's negative sine what? Negative sine x. So that will be my expression. And then remember, I still have my 2 here. So for this one, I'll put the 2 first. So that's 2. Then in open the bracket to write the solution for this one. That's negative 2 sine x cos x. Or cos x sine x. It's the same thing. So this is my solution here. So that's my du over dx. So well, we can see that this one, we are not done, because here to cancel out, remember, we'll still have to cancel out some things there, but it doesn't look like my sine 2x. But well, we can still think about your trigonometric identities, where this is one of the multiple angle, using your multiple angle formulae. So you can take the negative outside, and then you have 2 sine x cos x. But you have to see this from trig, that this is just what? So the negative 2 is outside, negative 2. You have to see that this 2 sine x cos x is just sine 2x. If you think of your multiple angle formulas. If you think of your multiple angle formulas, that's just negative 2. So 2 sine x cos x is sine 2x. So that's your derivative. So du dx is negative 2 sine x. So this is a bit messy. So I'll write it here. So my du dx is equal to negative 2 sine what? Sine 2x. And then you make dx subject to the formula. I'm sure we now get the gist. So this is negative du over what? Over 2 sine 2x. So this is my dx. So let's go ahead and simplify. So it means that this integral now becomes the integral. I have my sine 2x there, sine 2x there. Then inside the brackets, that one plus 2 cos squared x, remember, it's just the u to the power half. And then my dx is negative du over 2 sine what? 2 sine 2x. And then from here, you can cancel out sine 2x, and then this is negative, and this is 1, so it's like negative 1 over 2. You can take it out of the integral sign to have negative half outside. Then you integrate u to the power half du, u to the power half du, giving you negative 1 over 2 multiplied by the integral of u to the power half is u to the power half plus 1 over half plus 1, then plus c, giving you, so negative 1 over 2 multiplied by u to the power, so half plus 1 is 3 over 2, 3 over 2 over 3 over 2, then plus c. Simplifying this, that's negative 1 over 2 and then multiplied by, so u to the power 3 over 2 over 3 over 2, we can reciprocate this to get 2 over 3, then multiplied by u to the power 3 over 2, then plus c. So this is just a simple division. The division changes to multiplication, this multiplication, and then the 3 over 2 reciprocates. The denominator becomes the numerator becomes the denominator. And then the half, the 2 and the 2 can cancel here, so that you can have your final solution, which I can write just right here in red. That's equal to, and then in the process of writing the final answer, I also replace the u there. That's negative 1 over 3. So negative 1 over 3. So negative 1 over 3. Then u is what? 1 plus 2 cos squared x to the power 3 over 2. If you want to simplify it further, I can say this is negative 1 over 3. And then you have the square root, which is the 1 over 2 there. 1 plus 2 cos squared x. But remember, it's 3 over 2 now. So this whole thing should be the power 3, then plus c. That's your final solution for this particular question. So that's our solution for part C. Okay. Okay, now look at another one. So it's just a general idea of how you go about some of the differentiation question by U substitution. So let's now look at part H. So this question that I'm leaving out, you can always try to consult. If you're not sure, we are always available. You can consult Dr. Paul, you can consult me, Dr. Isaac. We'll be there to help and guide you through. Okay. So let's look at part. Let me go to part H. Part H gives the integral of the square root of the sine inverse of x, then 1 minus x squared. So this one, you have to think about the derivatives of inverse trigonometric functions, because sine inverse of x is just an inverse trigonometric function. So this is the same as me saying I have an integral. Remember, by properties of surds, if I have the root of a over b, this is the same as having the root of a over the root of b. So I can distribute the root there. That's root of the sine inverse of x, the sine inverse of x over over the root of 1 minus x squared dx. So you start thinking now, so how do you evaluate this integral? So to evaluate this integral, basically what you say is you have to choose which one to let to be a u. But if you remember very well, if I have a function y is equal to sine inverse of x, the derivative of sine inverse of x, the dy dx here in this case, the derivative of sine inverse of x is just 1 over the square root of 1 minus x squared. So this is the derivative of an inverse trig function. So you can even see from here that, oh, okay, this will be easier. So if I let you to be sine inverse of x, it's easier for me to come and cancel out these roots here, which you will see shortly. So you just let your u to be that sine inverse function, that sine inverse of x. And then du dx, so the derivative of sine inverse of x, I've just stated it up there. That's 1 over the square root of 1 minus x squared. Making dx subject to the formula here. So if you cross multiply here, the du will multiply with that root of 1 minus x. You're going to have root of 1 minus x squared. And then you have your du here. And this is equal to, so 1 times dx is just dx. And we've made our dx subject. So dx is equal to root of 1 minus x squared du. Let's go ahead and replace in our integral. So this is now equal to the integral of, so the sine inverse of x is u. So the sine inverse of x is u. So you have the square root of what? The square root of u. Then over, this one is still here, 1 minus x squared. Then multiply this by, or rather times, the dx. Just from finding out dx there, that's the square root of 1 minus x squared, then du. So you can see that the 1 minus x squared and the 1 minus x squared goes, so that you just have the integral of the root of u, then what? Du, which is just the same as the integral of u to the power half, u to the power half du. Remember, just from solving something that has a power of half, adding a 1 there, that's 3 over 2 over 3 over 2, then plus c, which will just give us, let me write it side with the blue. So that's u to the power 3 over 2. Then if I reciprocate that, I'll have 2 over 3 multiplied by 2 over 3, u to the power 3 over 2, then plus c. Then replacing back the u. Remember, u is what? Sine inverse of x, giving you 2 over 3, then the sine inverse of x, and then you put your what? The 3 over 2, then plus c. So this is your solution. If you want it, you can put it under the root, then to the power 3. It's still the same thing. So that's your integral there. That's your integral by u substitution. So we're done with this question. Which other one can we do? I think we can do I. Let's try and do I. Let's try and do I. So I'll rub again and do question I. So again, same thing. All you have to understand here is the derivatives and the integrals of the functions, trig functions, exponential functions, logs. So I'll not stop on emphasizing that. That's the only way you get to enjoy further integration. Okay, so integrating this function, the integral of tan z, then ln of what? Ln of cos z, ln of cos z, then dz. So just an integral in terms of z. So again, u substitution is me changing that integral from an integral in terms of z to an integral in terms of u. So how do I do that? So here again, you can see that you have a function in another function. You have what? You have a log, which is a ln, with another function inside, which is a trig function. So here you use, it's a composite function. So like I said at the beginning, you use what? You use substitution, and we've been taught to use substitution, so it's okay. So you let u to be this log here, ln of, which has a composite, cos z, that. So you have that function. So remember the derivative of what? Logs. So if I have a function y is equal to ln x, just in this case you have x, the dy dx of that function, the derivative of ln x is just 1 over what? 1 over x. But if I have a function y is equal to ln, but not x, but another function g of x. So again, you use what? The chain rule, where you say this is dy, the dy dx of that function is the same thing as just ln x. So it's 1 over, instead of x, we now have g of x. But don't forget to multiply by what? The derivative of the inner function, the g prime of x. So you don't forget to multiply by the derivative of the inner function. So this is a recap on derivative of ln. Okay, so that's what we're going to use here. So my du dz, because the function in terms of z, so du dz here is equal to, so like I've illustrated there, to be 1 over that function inside cos z, then multiplied by the derivative of the cos z. So remember the derivative of cos is negative sine. So that's negative sine what? Negative sine x. Negative sine z. And then we can simplify this further by saying this is equal to negative sine z over cos z. But remember again, these two from your trigonometry, from your trigonometry. So this implies that my du dz is just equal to, so sine over cos is what? Tan. So that's negative tan z. And then this means that if I make, so this is now making, not the, remember that the integrals we're doing were all in terms of x, that this one is in terms of z, so I'm making dz the subject of the formula. So making dz the subject of the formula, you're going to have a negative du over tan z over tan z. So this is my dz and this is my u. Then we go back to our integral and replace. So that's the integral. I have my tan z here multiplied by ln of cos z. So cos z is what? Oh, sorry. Ln cos z is u. So ln cos z is u. So you replace this with what? With u. So the whole thing, so times what? Times u times my dz is negative du over tan z. And then you can see that the tan z and the tan z goes. And then I can take the negative out of the integral sign and then just integrate what? U, then du. So this is how easy it becomes now. So from that complicated looking integral, you just have that by using your what? Your substitutions. By using your substitutions, you have that. And then this will be now equal to, what's the integral of u? So you have negative, that's u to the power 2 over 2. Just add the 2. Then plus c. Then replacing back our what? Our u to be negative, open brackets. What is u? U is ln. So I'll put these brackets. Then I have cos z to the power what? To the power 2 over 2. Then plus what? Plus c. So that's my final solution. That's my final solution there. So that's how you use your integration by u substitution. So this tutorial has been on working with integration by substitution. Yeah. Maybe we can also do G. So just as a bonus, let me do G. I can do G as a bonus. So G here. So G again, we use the same methods as we have used all this time. Okay, do this. Okay, so that's G, the integral of 5x plus 1 over 5x squared plus 2x plus 5 squared. Then you have your dx. So, well, this one, we can let you to be what's inside our brackets there. We can let you to be what is inside our bracket. So I'll let u to be that 5x squared plus 2x plus 5. And then, like always, you find du dx. Find du dx, you're going to get, so the derivative of 5x squared, you drop the 2, multiply that 5, you get 10x, then plus the derivative of 2x is just 2. And then here, what's the next step? We make dx a subject. So we've done this a bunch of times. So dx will just be equal to du over that 10x plus 5 plus 2, right? Okay, then you can see that, okay, but I'll have to divide with that. So how can I rewrite this? So, you can also write this as what? Du over, remember, you can factor out a 2. So that's 2. Then you have 5x plus 1. And it looks exactly like that guy in the numerator, which is going to cancel now. So this is equal to the integral of 5x plus 1 over, this whole expression is my u, but it is squared, times dx is equal to du over 2 5x plus 1. Then you can cancel these two out. Cancel these two out, and then you have the integral of 1 over 2u squared, like that. So this is equal to du. So this is equal to the integral. So you can take the u up. So remember, you only take the u up because the only expression that has the power is the u. So it's different when you have 2u squared and 2u squared. So these two are two different expressions. Here the power is only on the u. So I just take the u up and then the 2 will still remain in the denominator. So 1 over 2, then u to the power negative 2, then du, which gives me, so the integral here, I can even take the half outside, then multiplied by the integral of u to the power negative 2, u to the power negative 2 plus 1, that's negative 1 over negative 1, then plus c. So this will just give me negative 1 over 2, negative 1 over 2 times, so u to the power negative 1, then plus c. So let me write it in the middle with red color. So that's negative 1 over 2 multiplied by, so 1 over u. I can rewrite that u to the power negative 1 as 1 over u, then plus what? Plus c, giving me negative 1 over 2u plus c. But what is u? U is that big expression, 1 over 2, 5x squared plus 2x plus 5, then plus c. So that's the solution. You can even expand here by multiplying each and every term inside the bracket by what? By 2. But basically, that's how you integrate that. Maybe just to explain on the two I've left behind, which you guys can try out as your practice questions. So this one, you can just say it's the same as the integral of e to the power 2x over, that's f1 plus e to the power 2x to the power 3. So as always, you let your u to be this guy inside the brackets. You find your du dx, then you make dx a subject to the formula, and then you replace, you see that things will start canceling out. But maybe just to explain on the derivative of e to the power 2x. So the derivative of e to the power 2x is what? So dy of e to the power 2x, this is an exponential function. Remember, if I just have e to the power x, the derivative doesn't change. It's just e to the power x. But if it's a function of x now, then you use the chain rule where we say this will be equal to, so the derivative will be equal to, it will be e to the power, the same 2x, but you multiply by what? The derivative of the power, the derivative of the inner function, which is that 2x. Well, the derivative of 2x is just 2. So it will be 2e to the power 2x. That will be the derivative of e to the power 2x. And then you can simplify nicely there. Part C, you have x to the power 3. Part C, you have x to the power 3. You have x to the power 3 over root of 1 minus x to the power 4. You can even see from there that even so you say that, okay, you let u to be that guy in the brackets under the denominator there. And then you find du dx, which will give you some sort of x to the power 3, which is going to cancel that numerator there when you make your dx the subject of the formula. And that's all on integration by substitution. So if you have any questions, feel free to reach out. We are always available to help. So thank you very much for watching this video. See you in the next session. Thank you very much.